So in our last video, we did the first derivative and got the increasing and decreasing and the maxes and the mins. And now we're going to do our second derivative. And this is where cleaning up this derivative was very important because we need to use that to do our second derivative. Again, we're going to use the quotient rule on this thing right here. So derivative of the top is going to be 2x. And let me pull up another page here. So second derivative. And our bottom was x squared, so we'll just tag that along. And then we want the derivative of the bottom. Derivative of x squared is 2x. And then our top will tag along, and our top was x squared minus 3. So and then we put all of that over the bottom squared, and our bottom was x squared, so that's going to give us x to the 4th. Alright, so definitely we want to clean this up. So let's see, that's going to give me 2x to the 3rd minus, and if I multiply the 2x through, 2x to the 3rd plus 6x. Over x to the 4th. Our 2x to the cube will cancel out, which is nice, and we get 6x over x to the 4th. And we can reduce those x's and we get 6 over x to the 3rd, which is nice because there's no place where the top is equal to 0. The bottom is equal to 0 at x equals 0. So that's the only critical value. So let's put that on a sign chart. It's the only one. And let's choose something to the left of 0. Let's say -1. If I plug -1 into this derivative, the top, of course, will be positive, but -1 to the 3rd is negative. So positive over negative, this is negative. If I choose a 1 over here to the right of 0 and plug that in, I'll get 6 over 1, which is positive. Alright, so we get our concavity from this derivative. So from negative infinity to 0, this graph is going to be concave down. And from 0 to infinity, this is going to be concave up. Now, as we consider inflection points, let's make sure that 0 is actually defined in our original function. So in the case of the original function, if we go back and look at it, 0 was our vertical asymptote. It is not defined. So we do not have an inflection point there because that is the vertical asymptote. It's an undefined place. So there's no inflection point. So it's not an inflection point. All right, so no inflection points. So always be careful about the value you get, that it's not an undefined point. Okay, now we have all of our information. We're ready to graph this thing. So let's graph this function. So first, let's keep in mind that x equals 0, or the y-axis, is our vertical asymptote. We do not have any x or y intercepts. We have increasing and decreasing values, but let's go ahead and plot our maxes and our mins first. So we'll go back up to the top of this. We have a max at -1.7, -3.5. All right, so a max at -1.7, -3.5. So -1.7 is right in there, -3.5, somewhere right about here. Now let's keep in mind that that's a max. All right, and then if I go back to the previous sheet, we have a min at +1.7, 3.5. All right, so a min at positive 1.7, 3.5. Okay, so 1.7 is about there, 3.5 is right there. You might say, well, how's that one a min when it's higher than this one and this is a max? This is where we really got to pay attention to the fact that there's a vertical asymptote right here. Our increasing, our decreasing are very important. So we can guess it's increasing here and decreasing after. And we will see as we go back. Let's look at the increasing and decreasing. I think I have to go back to the others. So starting with our increasing, this graph is increasing from negative infinity up to negative 1.7. Let's notice also during that increasing interval, it is concave down the whole time. So let's draw increasing and decreasing and concave down. So I don't think I said decreasing, didn't mean increasing and concave down until it gets to here. It looks like that. All right. And then after that, it was decreasing and concave down until it got to 0. So decreasing, well, it's going to go down toward its vertical asymptote. So it's going to go toward this. All right. So there's the left side of the graph. All right. There's a vertical asymptote here. So we're going to a second piece as we go across that vertical asymptote. All right. So if we look back at our information, the graph is, let me look at the second one. The graph is decreasing from 0 to 1.7, and it is concave up. All right, so decreasing, concave up, coming from this vertical asymptote, decreasing, concave up, looks like that. And then if we look back, it's increasing afterwards, still concave up, looks like this. Right? And there's our graph. Now, these are more than likely hyperbolas, so probably this is actually kind of branching out a little more, like that. But there is our graph.